Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is evaluate reverse polish notation, or also known as postfix notation. You are given an array of strings tokens that represent an arithmetic expression in a reverse polish notation. Okay, so those of you who do not know what a reverse polish notation is, a link for the definition is also provided. Evaluate the expression, return an integer that represents the value of the expression. Okay, so following things are mentioned specifically. That the expression will only contain these operands: plus, minus, multiply, and divide. Each operand may be an integer or another expression. Okay, the division between two integers is always truncated towards 0. Okay, there will be no division by 0. You can assume this. The input represents a valid arithmetic expression in a reverse Polish notation. So you are given a valid input. You need not to worry about the checking of edge cases. The answer and all the intermediate calculations can be represented in a 32-bit integer. So you need not to worry about your intermediate result or answer going out of the bounds of a 32-bit integer. So these are the things that you should be keeping in mind while solving this particular problem. Okay, now let's see the constraints. Length of the array that will be given to you will be of order 10 raised to power 4, and each token can either be an operator, plus, minus, multiply, or divide, or an integer which is an operand, and which will be ranging from minus 200 to plus 200. Now let's see how we will be solving this particular problem. We are taking the second example given in the problem. What we are required to do is we are required to traverse the string in this fashion, but we will be applying operations like this. Okay, and let's say this is x. Then we will return 4 plus x. This will be your result. Okay, so what we are doing here is, first of all, to know how to evaluate a postfix expression, you should be visiting this, or reverse Polish notation, you should be visiting this link, or you can search over the internet also how to evaluate a postfix in notation or reverse Polish notation. Basically what happens is, whenever going from left to right, you see a operator. This was a operator, what you do is you see what were the last two operands, apply this operator on last two operands visited. Visited, or you can say, if we are storing all the operands in a bag like structure, okay, and we are concerned with the last values that we inserted in the bag, then this bag like structure is working in last in first out manner. Okay, so this can be implemented with the help of a stack. So first of all we will push 4, then 13, and then 5. So let's say you are at this particular token and you see that it is a operator instead of a operand. What you will do, you will pop two values from the stack, okay, last, which will be last two operands that are present in your bag or present in bag, which is nothing but a stack since it is following last in first out order. Okay, now you will pick them. This will be your first left hand side operand, your, let's say, first element, and this one will be your second element. Why we are not considering this one as the first element? Because all the values were inserted in this order. Okay, so first element will naturally be 13 instead of 5. So what you will do, you will apply the operation first element, so this will be the operator, and then second element, and get the result of this particular equation. And store whatever will be the result of this particular operation into the stack. So 5 and 13 will be removed from the stack. Instead of them we will store the result. Okay, so if you divide 13 by 5, it will be nothing but 2. Okay, so you will be storing 2. Then comes the plus operator. You will again pop two elements and apply the operation. It will be 6. So answer should be 6. As you can see, it's 6 only. So this is how you will be solving this particular problem. Okay, now let's see the implementation. This is the implementation. Let me quickly zoom out. Okay, and this will be the operand stack. Only numbers will be pushed here. Data structure, and it will operate in LIFO manner, last in first out. Okay, and if your current token is a special character, it means it is a operator. Current token is a operator, not character. Then you will pop to first and second element from the stack. And and apply the operation on them, and then push the result to operand stack. Okay, else if that's not the case, you are having a number at your hand, then you will push it into operand stack. And at last you will return whatever is the value present in the operand stack. That will be your result. Okay, so these two functions are nothing but to check whether the current token is a special character. Okay, and this is to apply the operation. First element in whether the operator is multiply, then you will multiply. If it's divide, then you will divide. If it's subtraction, then you do subtraction, and if it's addition, then you will do addition and return the result. So this is how we will be solving this particular problem. And if you ask what will be the time and space complexities, for time complexity, it will be order of n, and for this particular operation, it will take whatever is the maximum length of token. Maximum length of token was 200. Maximum length not 200, actually you can see it is as a string, and if this is a string, then it is of only 4 length, maximum 4 length. Okay, so 4 is a constant, so we are not bothered about it much. So where n is the size of the tokens array, which is, by the way, 10 raised to power order of 10 raised to power 4. Okay, so space complexity wise, it will be nothing but order of n only, since operands will be there. So actually it will not be equal to order of n, since n is the size of the tokens array, but it will be close to order of n, so you can take a loose upper bound and it can be said that it will be order of n. Okay, so that is there, and this is how we will be solving this particular problem. If you are having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.